All right, number 4 on our Unit 3 FRQ review, we are told that f and g are differentiable functions. Selected values of f and g are given in the table. And then we have this third function h, and it is defined as h of x equals 2x plus the product of f times g. So again, if I write f of x next to g of x, that implies that there's multiplication there. So, all right. Question A, explain why g must have a horizontal tangent line on the interval that include, from 1 to 3, that doesn't include 1 and 3. So the open interval from 1 to 3. And explain your reasoning. So I might have to think about this for a moment, but I know that if, well, first of all, I know that the derivative of a function yields the slope of its tangent line when I input a value, a particular value. And I also know that a horizontal line has a slope of 0. So I will need to communicate that I know those things in my answer. So I might even just start with the first fact and say like a horizontal tangent line has a slope of 0. Really, any horizontal line. It doesn't have to be a tangent line. So again, if I go back and think about this problem, this is telling me that g must have, the function g must have a tangent line at some point or for some value x between 1 and 3, where the slope of that tangent line, aka the derivative, equals 0. So now I'm thinking about some theorems that I know, and I know of one theorem that can guarantee a value of the derivative, and that's the mean value theorem. So remember, the mean value theorem can guarantee that the average rate of change of g at some point is equal to the, over some interval rather, is equal to the instantaneous rate of change of g between the x values of that interval. So remember, the instantaneous rate of g, that is g prime, or g prime of x. So before I can use the mean value theorem, I need to make sure that the function g that I'm working with satisfies the hypothesis. So the hypothesis of the mean value theorem is that the function g must be both continuous and differentiable. And again, I can't just state that. I've got to go back to what I know. I am told that g is a differentiable function. So the fact that g is differentiable, that implies that g is continuous. And the order in which we write these two statements is important. All right, so now I can use the mean value theorem. So again, I'm looking at values of x on the interval from 1 to 3, and values of x, but I'm looking at g values. So if I look at the actual g values, g of 1 and g of 3, they're in my table. I notice they're the same. So if I think about slope as my change in y over my change in x, well, from 2 to 2, y didn't change. I understand that it changes between those values, but we're really looking at the slope from 1 to 0.1 to 0.3 because we're talking about the slope of a secant line, so our average rate of change. All right, so I'm going to show that, and I have to show this to get credit for the mean value theorem argument that I'm about to make. So I have to show that difference quotient. I'm going to plug in those values. That's 2 minus 2 over 3 minus 1. And since 2 minus 2 is 0 over a non-zero number, my derivative is 0. So I could now conclude and justify my conclusion. So I could now say, like, by the mean value theorem, which you can definitely abbreviate as long as that is an M and not an I or, I don't know, any other combination of letters. By the mean value theorem, there must be some value. They didn't give us like a C or something, so I'm just going to say of X on the interval. We could use that symbol. It really means is an element of, from 1 to 3, parentheses there, because I didn't have or equal to signs up there, such that, and I want to be careful here, the mean value theorem has nothing to do with a horizontal line. What I can conclude from the mean value theorem is that G prime of X at one of those values equals 0. So by the mean value theorem, there must be some value of X on the interval from 1 to 3 such that G prime of X equals 0. And then we kind of already said this. I realize it's a little redundant, but we have to include this fact, so I'd rather be redundant. So since a horizontal line has a slope of 0, G must have a horizontal tangent line. I think I could abbreviate that since I already wrote it out, between X equals 1 and X equals 3. All right, there might be other ways that we could write that, and I realize that's a little bit redundant, but it's maybe better to say that twice about the horizontal tangent line having a slope of 0 than to risk not saying it, because again, the mean value theorem just guarantees the value of the derivative. It is our job to supply the reasoning for there being a horizontal tangent line there. All right, part B, we are asked about the function f now, so be careful that we don't mix up values in our table. So f has at least how many zeros, that's worded kind of funny, at least how many zeros on the interval from 0 to 4. So we are just considering values of f. I'm going to just highlight it so I don't look at the wrong information. We're looking at all the values in the table, and we want to know essentially the least number of times that f must equal 0. Because when we say f has a 0, that is where f would equal 0, or where y would equal 0 if I'm not using function notation. All right, so again, I know f is differentiable, which means f is continuous. That means I can apply the intermediate value theorem. So if I think about all these points that are on the function f, I've got 0, 3, 1, 1, 2, -1, 3, 2, 4, -3. I know that f must have a 0 here because my y values or my f values change from a positive to a negative, and also here. And when I almost missed one, and then also here. So there must be 3 zeros, right? There could be more than 3 zeros. There could be a lot more than 3 zeros. We only know some selected values of f. We don't know what the function f is. So, all right, so I might start by first answering the question. So I might say f must have at least 3 zeros. I would at least spell one of those numbers on the interval. You just kind of copy how that's worded. All right, now we haven't explained our reasoning yet. And when it says explain your reasoning, we might show work, but that does imply that we're going to do some writing there. We said it's the intermediate value theorem that guarantees this. So remember, if I'm using the IVT, I must first establish the hypothesis. And we've not done that yet. We've only talked about the hypothesis in part A, and that was for G. So now I need to talk about F. So again, F is differentiable. Well, the hypothesis of the IVT is that f must be continuous on that interval. So remember, if a function is differentiable, that means its derivative exists everywhere, and that means it must be continuous everywhere. So that's why differentiability implies continuity, not vice versa. Be careful, that logic is not biconditional. So f is differentiable, therefore f is continuous, so the IVT applies. So I could say now, by the intermediate value theorem, you can write IVT. Let's see, sometimes I need to think about my head before I write it. I'm going to say f must equal 0 between, let's see, and I'm going to use values of x, so f must equal 0 between x equals 1 and x equals 2, comma, because we're listing, right? X equals 2 and x equals 3, comma, and then finally x equals 3 and x equals 4. Now, I'm not really sure why my brain didn't just use interval notation just then. You could have also said, like, you could have used the language on. We usually say on an interval. So you could have said like 1 to 2. And then what, 2 to 3. And then our last one would be 3 to 4. All right, so you could also do it that way. I'm not really sure why I didn't. It's just not how I thought about it just now. All right, so okay, here's where I need to be careful. When we talk about establishing betweenness, we have to establish that the value of f is between those y values. So we're still not done. I know it's kind of a pain to write these IVT explanations, but it is like just a few sentences, so we will survive. All right, so by the IVT, f must equal 0 between those values, because this is the part to me that's easy. We just got to remember it. 0 is between, and now I'm talking about y values. So make sure you write y values, not x values here. So you could say f of 1 and f of 2. Those are y values. It's the function f at that value, comma, f of 2 and f of 3. And then finally, f of 3 and f of 4. All right, you could also just use the actual numbers. So like instead of f of 1, I could use the number 1. Sometimes I think it's less confusing to write it in function notation. All right, so when we establish betweenness using IVT, we're establishing that the y value that we're guaranteeing is between the y values of the function. All right, part C, find the average rate of change of h. So now we're talking about the third function, h. We want to be real careful that we don't use the wrong function. On the interval from 0 to 4, show the computation that leads to your answer. That's a real fancy way of saying show your work. To me, that does not imply that I need to like write a sentence. So again, when I go to do this, before I do average rate of change, I'm just going to find h of 0 and h of 4 first. So h of 0, I'm just going to take my function h from the top. You don't need to draw this arrow in your work. I'm just doing it for illustration. And I'm going to substitute 0 everywhere I see an x. So this becomes f of 0. I am going to put a dot there so I don't forget that I'm multiplying, times g of 0. I'd strongly encourage you to write it that way first. Sorry, I'm dog sitting. The dog is barking a lot. All right, sorry, I'm hoping she'll stop. I'll give her a minute. All right, so then I'm gonna now I've got to fill in my values for f of 0 and g of 0, and I know that 2 times 0 is 0, so you don't have to write it, but I'm going to so I don't make a mistake. All right, in my table, I could see f of 0 is 3, so that's the number 3. G of 0 is 4, so h of 0 is 12. And because I am like obviously writing these things under each other, I can stop writing h of 0 as long as it is crystal clear that those equal signs are linking that statement to the statement above. So just be careful there. All right, then I've got to find h of 4. So same thing, I'm going to substitute a 4 anywhere I saw an x before. All right, so 2 times 4 is 8. F of 4 times g of 4. Well, f of 4 is -3. G of 4 is 7. So 8 plus -3 times 7. I know order of operations, that is 8 plus a -21. And you know me, I'm not super great at doing math in my head. So what is that? That is what, a -16? No, it is not. I lied. That is definitely a -13. I've just done too much math today. Do you ever have a day like that? All right, now we still have to find the average rate of change, but now I don't have to show that work in my difference quotient. All right, so my final step is when I'm now finding the average rate of change, I still need to show that difference quotient. And here we got to be so careful. We cannot accidentally call this like F or G, because I will not get credit if I don't write an H here. So h of 4 minus h of 0 over 4 minus 0. Well, h of 4 we said is -13 minus h of 0, which is 12. All of that over 4. And I know -13 minus 12 is -25. So -25 fourths is our average rate of change. I would encourage you to just leave it. You don't need a decimal. Just leave that as -25 fourths. Can't be simplified. All right, last part. Show that there must be a C between 0 and 4 such that h of C is 7. So again, the way this is worded, I am asked to guarantee a value of h, and I'm working with the function h. So if I can apply it, that's the intermediate value theorem. But remember, I can only apply the IVT if h is also continuous. So going back to what we know that f and g are differentiable. And we have already in, I guess I should do that. We have already in part A asserted that g is continuous. In part B, we asserted that f is continuous. So we don't have to restate, well, we actually kind of do to say why h is continuous, but we don't have to go back to how we know f and g are continuous, because again, we have already stated that fact in part A and B. So we can carry our reasoning down with us through the problem. I just can't start at part D and work backwards that way. So we know that h is continuous because f is continuous, g is continuous, and 2x is continuous. That's just a line, like y equals 2x is a linear function. So I don't even think we need to state all that. Here's what I would write. I would write f and g are continuous. And again, we can do this because we've already stated how we know. That implies that h is continuous. Now, it might be a better answer if I also address the 2x piece, but most of the rubrics I've seen would let us get away with this. All right, so we already found h of 0 and h of 4. And I don't think we need to find those again, but we still need our IVT justification. So we could say, by the intermediate value theorem, there must be a value C on the interval from 0 to 4 such that h of C equals 7, because 7 is between, well, h of 0, or you could say 12, or you could say h of 0 equals 12, and h of 4, which is -13. So since the y value 7 lies between 12 and -13 on the y-axis, because that function is continuous, we know that h must pass 7 on its way to -13. but don't write that how I just said that. Write it how I wrote it. All right, that would earn us all the points on that type of question.